Hello and welcome to the logic of it all. In this video, we will talk about breadth-first traversal. In the previous video, we talked about depth-first traversal, and it's best if we understand this new algorithm, BFT, in comparison to depth-first traversal. Now, the first intuitive way that we can talk about this algorithm is we start from a root node, and then in the next stage, we explore all the nodes, all the vertices that are adjacent to the root node. So instead of going deeper and deeper into the graph, we cover the breadth. We cover all the children of the current node before going one level deeper into the graph and explore the children of the children and so on. So that's the first immediate difference that you should notice between BFT and DFT. Another way of thinking about this intuitively is, instead of following a path all the way through until we hit a dead end and then backtracking, in breadth-first traversal, we expand all paths equally until we reach the end and so on. Or if you remember, in depth-first search, we said we visit children first and then the siblings. So you're starting from the root node. First you visit one of the children and then one of the children of that children and so on. And then when you hit that the end of that path, then you backtrack and visit other children. In breadth first search is the opposite. We visit the siblings before going deeper into the next level of the graph. Now, all of this is very informal, but it should be good enough to build some type of intuition around this idea. And later on in this video, we will explain everything in full detail and rigor. Now, here's an example that I picked from Wikipedia. So as you see, we start from root nodes, which is labeled with 1, and then the nodes that we explore later are all the children, 2, 3, and 4. And only then, after exploring all the children, 2, 3, and 4, we go to the next level and explore 5, 6, 7, and 8. And then only after that, we go one level deeper and explore 9 and 10 at the bottom, which is quite different than depth-first traversal. Now, how is it really implemented, right? What are the details? So similar to DFT, here we also have two subroutines. One is the top level that I'm calling here breadth traversal. And the only thing that this one does is it initializes the lists that we maintain while performing the task. So we have a traversal list, which is initialized to empty. We have a to-do list, which is initialized to empty. And also we can still keep track of a visited list as well. And that is also initialized to empty. And then after that, breadth traversal calls the recursive procedure or recursive function BFT. And most of the work is done in BFT, which we will explore in the next slide. So this one is only the top level one that we call once, and then it initializes the lists and calls the recursive function, which is BFT, and then recursive function, by calling itself over and over and over, takes care of the traversal, and at the end it returns back to this function, and we terminate by the return on the last line. Now let's take a look at BFT itself. So the parameters are the graph itself, which is given as an adjacency list, and a vertex, which is the vertex that we are starting from. Now, the first thing that it does is that it puts V in the visited list, because now we have visited V. So V should be marked as visited. And also, remember that we have a traversal list similar to the previous algorithm. So now that we have visited D as part of the traversal, V is added to the traversal list as well. Now, what we do next is we look at all the children of the current vertex. So here's the if statement down here. If the adjacency list of V has vertices that we have not visited yet, those are the ones that we are going to explore. So what we do is we append them to the end of the to-do list. Okay, so the to-do list was also initially empty. Now here what we do is that after visiting V, we look at all its adjacency list and all the vertices there that are new, that have not been visited before, are added to the to-do list to be visited later. Now we need to decide where to go next. And to do that, we use the next if statement. And the if statement looks into the to-do list. If the to-do list is empty, we are done, and that's the end of this recursive call. But if the to-do list is not empty, then what we do is we look at the first element of the to-do list, and we call that, let's say, W. And we check whether W has been visited or not. If it has been visited, we ignore that and go and look at the next element and the next element. So we have two lines inside the do while loop. If you pay attention to that, on the first line we say assign W to the first element of the to-do list. So we call the first element of the to-do list W, and then we remove it from the to-do list. But that's not the end of it. Then we have the condition that says while W has been visited and the to-do list is non-empty. So if W has been visited before, then we go back to the top and call the next element, which is now the first, W again, and remove that from the list. So we keep doing this until either the to-do list becomes empty or we find a W that is new, that has not been visited before. And in that case, in the last if statement at the bottom, we recursively call BFT starting from W. So that's starting over from this new vertex W. So that's the entire algorithm. Now, obviously, again, this is kind of abstract. So through this example, we are going to explain all these steps in full detail. So this graph is given to us. It has 6 vertices and is given in a form of an adjacency list. And what we want to do is we want to perform BFT on this graph, breadth first traversal. So here's how it goes. First, we start with the initialization. So we initialize step 1, we initialize our traversal list to empty. So TL is empty. Our visited list is also empty. And we had a to-do list that I'm going to call TD that is also initialized to empty. Now we need to start from a root vertex, and the algorithm allows each vertex that we want to be considered as the root. But if you remember, we said before that the convention is whenever you have a choice between multiple vertices, you go with the one that is alphabetically first, which means that I start with A. Now, what happens is that first of all, in my traversal, A is the first vertex that I have visited. So I put that in my traversal list. Now that it has been visited, I add that to my visited list as well. And now my to-do list is going to be everything that is adjacent to A, everywhere that we can go directly from A. And that includes, from A, I can go to B, I can go to C, and also I can go to D. So I'm going to add these 3 to my to-do list to visit them later. B, C, and D. Now it's time to pick where we should go next. So now we need to pick W. And if you remember, W is going to be assigned the first element of the to-do list, the first from here. So, and then we remove that. That was the second line in the do while loop. And then the check was whether this W that we have picked is visited or not. And if it's not, we continue. If it is visited before, then we need to repeat this process again and pick the next one. But in this case, B is not visited. V contains only A. So B is a new vertex, which means that we go to the next step. So now my traversal list contains A, and then after that, I went to B. Now the list of vertices that I have visited so far includes A and B. And my to-do list consists of C, D. And then currently we are at B. We are here. So now I need to look at all the vertices that are adjacent to B, everywhere that I can go directly from B. And that includes, I can go to C, D, or E. So what I need to do is I need to add them to the end of my to-do list. So I add C, D, and E here. Okay. Now, it's important to note that when we are adding these new vertices to our to-do list, we add that to the end, but when we are picking our W, we pick that from the beginning. And this is, from a technical point of view, what causes the difference between breadth first traversal and depth first traversal. Now, if you want to get more technical about it, this is not the module for that, but in terms of the database used, I'm sorry, in terms of the data structure used in depth first search, we use a stack, and here we use a queue. But in any case, we pick W again as the first element of the to-do list, which is C. We remove that from the to-do list, and then we check whether this W that we have selected has been visited before. It's not inside the list, V, which means that this is a new vertex, and we can move on. So now my traversal list consists of A, B, and then C. The set of vertices that I've visited so far is the same, A, B, C, and my to-do list now has D, C, D, E, and note that we are currently at C. So let me move this to C. We are here now. First we were at A, from there we went to B, now we are at C. And now I need to see which vertices are accessible from C directly. I can go either to E or to D. It has only two outgoing edges, and D and E, none of them have been visited before, so I need to add them to my to-do list. So D and E. Okay, now what's the next step? The next step is I need to decide where should I go now. So now it's time to pick our W. Remember the do while loop, right? So we set W to be the first element in the to-do list, which is D, and then remove it from the to-do list. Then check to see whether W has been visited before. It's not here, it's not in V, which means it's new. So I immediately go to the next step, and traversal list becomes A, B, C, and D. My visited list becomes A, B, C, and D. And my to-do list becomes C, D, E, D, E. And now we are at vertex D. So we are here. So where can we go from D? We can only go to E. So I need to add E to my to-do list. And E has not been visited, so I need to add that. So what's next? We need to pick W. I set W to be the first element in the to-do list, which is C. But that's not acceptable because C has been visited before, so I continue the second iteration in the do while loop. So I set W to be, so this is not acceptable, so now I set W to be D. But D is also visited, so this is not acceptable either. So I set W to be the next one, E. And E has not been visited before, so that's acceptable. So in the next step, I go to E. So now my traversal list is, I started from A, I went to B, then C, then D, and now E. And visited is, I've visited now A, B, C, D, and E. And my to-do list consists of, so we set W to be E, so this is also removed. So now what I have is D, E, E. And where I am currently is, I am at E. So I'm here. Now where can I go from there? I can go to F, and F has not been visited before, so I need to add that to my to-do list. Now I need to pick W. So let me start it from a little bit higher up here. So I pick W to be the first element, which is D. I remove it from my to-do list. But D has been visited before, so that's not acceptable. So I set W to be the next element, E, and I remove it from the list. But E has been visited before, so this is also not acceptable. The next element that I assign to W is E again, so we know where that's going to go. That's not acceptable. And finally, W will be assigned to this one, F. I remove F from to-do list. F has not been visited before, which means that I can continue now to the next step, which happens to be the final step. So now my traversal list is, I went from A to B to C to D to E to F, and currently I am in F, down here. My visited list, the vertices that I've visited so far are A, B, C, D, E, and F, so all of them. And what is my to-do list? My to-do list is empty. And from F, I don't have anywhere new to go, so I don't have anything to add. So my to-do list remains empty. And now I need to pick my W, but the to-do list is empty, and that was one of the conditions of the do while loop and the if statement after that. So we skip the to-do list, we skip the while loop and the if statement after that, and the recursion terminates here. So that's the end of our breadth first traversal. And here's the same calculation in a nicer format for you.